truth and machine, shaping reality in every routine.
Good morning and welcome to the Veritas Automata Deep Dive. I'm Ben Savage, the CEO and founder of Veritas Automata. With me, I have Dr. Sarkar. So Saurabh, we've been talking about redoing our theme song, and I've been playing with some different ways on how we could generate the lyrics and the summaries for it. So, before I forget, for our audience, please like, subscribe. We'll do the millennial thing, but what we really want are questions, comments, things that give us feedback so we can help make this a better podcast for everyone. But back to what I was talking about, we talk a lot about AI and vibe coding and all that. And so my answer on the way to create a better theme song is that, one, I need to go through all the summaries, and we've got 20 plus summaries now, or 30 plus summaries now. And I don't want to do that manually, and I don't want to go through them one at a time. So of course, this means I need to create a new tool. And this is a really good excuse to go test different vibe coding tools or different AI assisted coding tools. So I started this with Kiro, which is Amazon's coding tool, which is very focused on spec driven. At the time I was starting to build these, Claude had just introduced their new desktop app, and they had a version of Claude developed as part of the desktop app. And they had Opus, is it 4.6 is their newest model, had just come out. 4.6. And they also gave a bunch of free credits to go test it. Mm-hmm. And then there's another tool out there, Open Code. So Open Code is kind of like Claude developed the CLI version, but it lets you work with most or any models, including local models. And another newer model had come out, Quencoder Next, which is I want to say a 70B or 50-some B billion parameter open source coding model that's supposed to be very good. So of course, I had to feed them all the same requirements. So now we're going to play a guessing game on which one is which version. So let me share my screen, Saurabh. Okay, so you can see the screen there. Right. So this is the first one. I'll just kind of go through the different screens because eventually this will be extended to integrate with AceStep so it can actually generate the music, but I didn't get that far. So it starts with here. I can go upload a document, go through the upload process. I can configure an analysis on like what kind of analysis it's going to do. And I can also choose which model it's going to use. And for this morning's versions, I ran it with LFM Thinking, which is one I'm starting to like a lot for small, quick stuff because it's super small and super fast. So good for running local. Here it ran the analysis. Here's where I can, as a user, review the analysis, and I can look at the themes it identified. And then I can go to the generate lyrics page, and so edit lyrics is where I need to go now, because here's where I can see the lyrics for the song. So I can go to the verses, to the bridge, so I can go edit the different pieces. And this one did a nice job of summarization here. So this is option A. Option B is here. And so you can see it gives me a little bit different version. I asked them all to use Split for the UI, so they're going to be somewhat similar. But here I can go through, I can upload. The other one, I can go configure my analysis. I can go choose my models. I can run the analysis and see different things. Here I can review the analysis. And so I said I used the Liquid LFM for the analysis. I then use Mistral 3B for the actual lyric generation. Right. So I go here into the lyric generation, and this one went a little off the rails, as AI does do. It didn't actually use the summary to go figure out what the lyrics should be. Yeah. But it generate lyrics. Yeah. And here's the last one. So starts with the homepage. I can upload, and you can see I've done different versions because, of course, you end up doing a lot of testing with these. I can go configure the analysis, so I can choose the type. I can choose my model. Here, if you haven't worked with Ollama, you do have to have either the built-in ability or the ability to tell it you're dealing with a thinking model, so it knows how to deal with the tags on the responses. And I can run the analysis here. This one didn't work, so I have broken something, as tends to happen. So let me see if I've got a old version of lyrics. No, let's go project history to see if I've got anything here. No, I don't have any good ones I can go back into. So let me pull this all off the screen. So based on that, just going in order the three tabs, if you think was Kira, you think it's Claude, you think
I think the second one is Claude. The third one is local. First one is Kiro. That's my guess.
you are spot on. So
Wow.
why do you say that between the three?
So the local was obvious. The last one, it was not, the way it was doing stuff, and the UX looked very, very rough. Kind of made sense. And then Claude, generally they are very good with UXs. I've seen Claude or ChatGPT, whatever equivalent Codex. They are good. You can see the cleanliness with that one, and it was able to hold the context, like you were setting it up. It would be multi-tab, multi-stage. It held that really well. And Kiro, I haven't played much with it, but again, I have not heard too much of a buzz around it. So I'm guessing it was a step behind Kiro in because the UX was again not as polished as the second one, where you have sliders, you have drop downs, the use of icons and stuff. Kiro is more corporate. You don't see much of the emoji icons dropped in. So you can tell like where is the DNA of those models are from.
So the interesting thing is, now I'm going to ask you a different question. Which do you think was the fastest one to build?
Fastest one would probably be Kiro.
Executed the whole thing the fastest.
So tell me, in terms of execution, did you give it one prompt or one requirement and then let it run, or did you do consecutively more iterations to finish the product?
So I took basically one prompt, but I did the spec-driven development approach in all of them. Well, to a point. Claude doesn't necessarily do that so much, right? But all of them, I try and go through here's the requirement, let's build a plan, and then execute to a plan was the approach I took for all three.
So my guess would be, in terms, again, the local one is probably slow because of, token output stuff. So that's a toss-up, but I'm thinking Kiro would be faster than Claude, because Claude tends to fork and do a lot of things, and you have to rein them back in quite often, and it's slow because it explodes a lot of them, and thinking, planning, all of that stuff is, and I think it's a significantly smaller context window compared to Kiro's. I don't know if that's true necessarily, but could be.
Kiro uses a mix of models, so I don't know its context window off the top of my head, because it does use some of the Claude models under the hood. Right?
So it's switching models. Okay.
It's really like the spec-driven development, where their big focus is the planning and then breaking it up into tasks, so you execute each task. And then it's got actually pretty good compaction and context management between steps. So the slowest was Claude, and the most expensive was Claude, because Claude tended to fill up its whole context window in its planning phase before it could go develop.
Yes.
So I burned through all 50 of those credits that it gave me, and then I had $50
worth of credit, right? $50 worth of credit.
So
wow!
All of those credits, including the weekly, and then I had to go wait for my weekly time to reset.
Yeah,
because the way Claude does, because I'm on one of their lower plans because I don't use it as much. So it was slower. Kiro was faster. The fastest was OpenCode though, and it got me. It was OpenCode with local. Now I was not actually running the model on my MacBook. I was cheating. I was running it on the DGX because I was doing it at home.
Okay.
But that would be the same thing. If someone had a 5090 at home, they'd be running faster. So, but my take is it got me 80 to 85% of the way there. Faster and a lot less expensive than the others. So it's like, I'm not 100% there, but it's getting pretty close to be able to do stuff local now.
What about the lines of code? Did you compare which one has a bigger code base versus the other?
I haven't done that, but what I'll do is I'll send you zips of all of them, and you can look at that. And how do we do an analysis? Because I'd also like to look at, are there any dead branches of code? Are there any any things? And like, I know security wise, because that's what all the planning tools told me, is like, because I ran it local, I didn't run a lot of security like login and all that stuff, and it was screaming at me about that from a planning phase.
Okay. Yeah, it will be interesting to parse those three code bases through some standardized security packages like Privy. I think that's one of the popular one where it checks for packages that's getting including, which has a critical bugs and stuff like that. We'll come back and report on on what the code quality was down the line. So,
Well, and I think for you to look at like how it approached the chunking strategy of the document to do the analysis and stuff. So
yeah,
it's interesting, but the key thing is you can get similar results, or you can get fairly different results, I guess is the right way to say it, using the same requirements in three different tools, because of the way that first step is when you're using an AI coding tools, how does it break up your requirements into something that's actually executable? Because if you're giving it, whether it's one document or a set of documents, it has to go break those up and say, okay, how do I get those into super detailed features or functions that can be built? So that's the first piece that's interesting. And then you get, how does the different model actually execute those features or functions from a code development perspective? And different models all have a very different way to go write their code. So you see, to your point, you see it go down different rabbit holes, you see different issues, you see it forget things. So there's like, how do you prime it to remember it's in the same repository if you've stopped for a day and you come back, so it doesn't restart on you?
I mean, the local models performing so well itself, is because some of the applications you can't really share the requirements with publicly because it's proprietary or something new product that you're developing. So if the local models gets you 80% of the way, you could bring in the big guns with Claude or Codex or the other Kilo to refine that model. So because the planning phase is all done, the architecture is set. So the big $50 you spend, designing the planning phase can be shortcutted out. So maybe it's a hybrid of multiple things, right? So.
Well, and that's on my list to continue experimenting with. I've talked with a number of people, and what they do is they even in the planning stage go, depending on what kind of thing they're planning or where they are in the stage, we'll start with Claude and have Codex review it, or start with Codex and have Claude review it, or they'll have Gemini review it, or they go back and forth on that. And then I've talked with a couple of folks, what they're trying to do is they use local coding to get the first 80% done. So they plan with an expensive model, local code. Then when they're finishing the details and all the debugging and all that, last 20% that takes forever to actually get a program to work as you go through and just dependencies and all the goofiness that we've all had happen when you program and have to get stuff, is the data in the directory you think it is, and all that kind of stuff. You kind of nail that down with a more intelligent model.
Right. And how well did Kilo stick with the requirement? Did you see adherence to the requirement, or did it make up its own things?
No, it stuck to it. I didn't have it. Kiro is very good once you've got a spec and executing to it. And I don't see some of the issues I've seen with Claude or some of the others where like it will start switching back and forth between libraries because it goes, well, I need to do this, and then it changes the library out. I have seen some issues with Kiro where it doesn't always fix tests. So it'll go through and say this test is failing and then kind of ignore it. You're like, that's core functionality, but it missed it. Now, what I did find, I saw this a little bit with Claude, and I saw this a lot more with OpenCode, was it will build the framework for the app, but miss the core logic that you're trying to build. And you have to go back after you're doing that initial pass and go, did you forget something?
I mean, that's fun times with coding. I think the new MacBooks came out yesterday, right? The M5 Max with 128 gigs memory. Now that makes a good use case to buy one because you showed us that the local LLMs are doing really that good, right?
Yeah, and that's, I was looking at the spec, and I need to dig a little bit more detail into it. Because my MacBook is an M3 Ultra, which is basically the same thing as the M3 version of the new M5 they just introduced. So the question is, looks like the memory bandwidth is the same, which is one of the things I was looking at. They're both 406, 409 gigabit memory throughput. So that's really, really cool that they've got the memory there. Because that was one of the complaints a lot of people had with even some of the Mac Minis is the memory throughput wasn't there.
Right.
It does vary based on the Pro versus the Ultra version of the chip, the Max versus the Ultra. I'm going to forget their CPU naming. The memory bandwidth is different. So the question is, have the M5s made enough CPU jump processing ability for me to say it's worth jumping from my M3? Because they didn't have an Ultra version of the M4.
Yeah, that was interesting because I think with M5 they have the dual die setup, which I thought was very different than what they have in the past. So I think I think looked at some of the benchmarking they were comparing as M4 Max versus M5 Max. There was some increment to in speed, performance, but it wasn't like revolutionary 2x or whatever. It was like 20-30% kind of in that horizon, right? So but yeah, what interested me was that 128 gigs lets you run 70B models because 64 wouldn't fit in the memory. So that gives you, I mean, it would be slower than having a A100 or A6000 GPUs, which are probably $8,000-9,000 worth of investment, and it's just a GPU, can't use it for anything else. But if it gets you at a slower speed, maybe that's worth thinking as well, especially as a local coding.
If you're working on agentic systems too, it's important. Like, because on this machine I run quite a few agentic things, so I'll run 3 or 4 smaller models all at the same time.
Yeah.
So that's where I was talking about that liquid LFM model or the Mistral 3B. So like as I'm doing some of this testing, I'll run like a Granite 4 Tiny, which is another I think a 4B model, Mistral 3B, like this LFM, and got a couple other smaller models I'll run. Not because necessarily I love their functionality, but because I'd rather see how different models behave in different things. But the nice thing is with a machine of this size, like I can run Nemotron or GPT OSS, still doing my other stuff, and I don't see a major performance hit. And those models for a lot of stuff are good enough if you're doing some basic kind of data analysis or something.
Yeah. I lost your audio for some reason. So you're having some technical issues. No, I don't hear you at all. No.
Can you hear me now?
Yes. All right.
Important lesson today, children, is charge your batteries before you start a podcast.
It suddenly went away. So I was fun to watch.
The mic battery died just a minute ago. So
okay. Maybe you want to. I guess your audio didn't get recorded either, right? So yeah.
We'll keep going.
Okay. So I think you bring up an interesting point. With this, you can potentially run things like OpenClaw or some of those agentic system where they use a lot of those smaller agents to run those. That enables to do that. But I'm not. Again, we were discussing a paper where somebody, I think, a researcher, gave an control to her inbox or his inbox to OpenClaw, and it asked it to clean it up. You want to talk about it? It was interesting to read.
Well, I believe that was one of the OpenAI people. So, because I think there's a lot of benefit for local models. Let's all be clear. Yeah. There's a lot of benefit for frontier models.
Yeah.
You just got to choose the right tool for the right problem, and you don't need to use the same tool for every problem. Is the way people need to think about it. Right now, people tend to just gravitate towards one thing.
Yeah.
But with OpenClaw, we talked on the last podcast. There's a ton of security issues with it.
Yeah.
And one of the issues that's going to be hard for any AI agentic system, and we've seen this even in some of the prototypes that we've built, is how do you get them to stop, or how do you know what the boundaries are, the guardrails are, so they don't go run off the rails?
Yeah.
So what you were talking about was, I think it was originally an X or a Reddit post from a from a OpenAI security person who was starting to use OpenClaw to help more with their email and with their other things. And they had a toy email box that they started to work with the agent on, and then they gave it access to their real email box. And they didn't have a good kill switch for their OpenClaw, and things went off the rails because they were doing the right thing and they were running on a separate Mac Mini. But because it had access to their real email, when they'd ask it to go do something with deleting emails, it interpreted that as delete star.star. For those of you who are a little bit younger, that is delete everything in the email box.
Yeah. I mean, that was funny to see that they were trying to send a stop command, but it wouldn't take it. So kind of begs to, hey, you've seen that behavior even on OpenAI or any of those platforms. It goes in a research mode, it does something, and you see it going in a wrong direction. You stop the pause button, it didn't stop immediately. It goes on rambling for a while and then stops, right? And then you have to do that. So maybe there is an architecture change or a tooling change that needs to happen, especially thinking, I get that piece. It doesn't really hurt it, but if it is doing tool call and deleting stuff, you should be able to interrupt it and take control away from it, right? So it's not necessarily a kill switch, but more of a, don't do that. It's process. You should be able to handle that, right?
Well, and I think it's one of the challenges as we all design these kind of systems is where do we put safeguards and safe rails in? And where do we put kill switches or other things that are more extreme? Because the challenge you're going to have with these is they're starting to think, or I'm going to use that term in quotes, right? Because remember, these don't really think. They find probabilities and then they perform an action based on what is the most probable. All of those things can be really hard to use conventional security or conventional methods around. So sometimes you're going to have stuff out of the loop to go hit that red emergency button.
What was the other paper we were discussing, early on? So the password generation using LLM, that was kind of interesting as well, because by design, LLMs are designed to predict the next token. How do you introduce randomness into that process? That was a kind of interesting concept to think about.
Well, and I guess the question is, right, are you using the right tool? So, to your point, right, if you're using a password generator, those are optimized with pseudo-random number generators or random number generation things to really drive high entropy, which means there's a lot of variability and a lot of a complete lack of repeatability in the password generation process. Whereas in a large language model, to your point, it's optimized for, we're trying to tune them to be more consistent and more repeatable. So if I ask a tool, I've asked to be consistent and repeatable, what's the password? And should I expect a good password from it?
Yeah, I don't know how much people are putting LLMs to auto-generate password, but I don't know either, because the password generation, the reason why someone would use LLM is to have a password which is not completely random but something memorable, because you want to quote from memory, right? But if you can predict that one out, then it's not very secure at that point. It kind of lays into the other paper we're talking about, where this public LLMs were able to recite books and copyrighted material like word per word kind of basis, right? So
before we go to that, I want to stay on the passwords for a little bit more, because it's one of the things, when we go through that paper or that article, one of the things they talk about is, like, to get an idea of how lack of random these were, they generated 50 passwords, 30 were the same. Or sorry, they generated 70 passwords and like 30 were the same or something like that.
Yeah, because it really,
it's the consistency. So it's an important thing. But this is where tool calling could be a great application. If you ask an LLM for a password, it calls one of the great either open source or commercial source password generation tools that are out there, and it gives you an actual random password.
Yeah.
Back to what we were talking about with OpenClaw, how do you make sure it consistently calls the tool when you tell it to?
Yes.
Is a different story.
Yeah, I think in any practical enterprise setting, that guardrailing becomes more and more important. You have a lot of these cool tools, but if they are not chained correctly, it's like having a nice pipeline of refineries, but your pipe's leaky and it's going, all of your oil's leaking out, and it's creating a mess and hazard too, right? So it may be really interesting, each of the blocks, but how do you join each of them, make sure they are guardrailed against, hazard? That's probably a good way to think about it. It's not the coolest technology, but it is essential for sure.
Yeah, and I think the other thing that we find too is the repeatability by being able to surface the data that's in the model, that latent data. That's the paper you were starting to talk about a moment ago, which is we know these were all trained on all kinds of content, from internet posts to novels and books and other forms of media. And one of the challenges a lot of those that they have had is they're being accused of mass copyright infringement because it can reproduce pieces of these books.
Yeah.
But what they found with this one is if you jailbreak some of them correctly or prompt some of them correctly, they can reproduce the majority of entire novels, not just a passage or a page, the whole book.
Yeah, it was interesting to see that I think they tested multiple different models, but how it's not a low effort exercise at all. Just to clarify that you have to push them around, nudge them around, and do a lot of tricks for it to kind of recite the actual books they ingested exactly. But it still kind of challenges the concept that the LLMs are learning the patterns and not memorizing the whole thing. It becomes more and more interesting because a lot of these models are heading towards that 1 trillion parameter or massive number of parameters. With that much of a memory, again, during the learning phase, it is probably easier to memorize stuff than extract statistical pattern, because you're not really forcing them to learn that, right? So if you recall, a couple of years ago, there was this concept of autoencoder, where you ingest something and compress it and then you expand it out. The compression actually forces it to learn the core concept so that it learns the physics of it, and then you can emulate the actual test results or the input data, right? So with throwing large number of parameters at it, I think we are at a point where they call the amount of input data that's available is all human content generation, and that is not massive unless you start to account the AI generated content as well. Then it's a feedback loop. But the real content is finite in number. It has all the so far how much content is on the internet, published books, all of that is still very, very finite in that sense. But you keep expanding your parameters, it is going to memorize because it's easier for it. It doesn't know what's memorization, what pattern extraction it is for. It is a loss function. It's trying to minimize that. It really doesn't care that much, right? So it brings to that interesting concept. The other paper we came across, distillation.
So before we switch papers, with that memorization fact, does that create an issue whether you're using a model with it trained or you're using a RAG or an embedding? Does this create an issue where sometimes it's going to replay content that you don't want it to because it's just easier for it to show that than to go find the pattern or use the pattern?
You have to nudge it in a way that the distribution matches, then it produces that whole thing. There is a thing in engineering, the hardcore engineering, where there is institutional memory and trying to fit the things that have been done in the past to the problem rather than finding a solution that really fits, right? It's that kind of, it goes into that thing because it's easier to, hey, I've seen this pattern before, it works with that, bring that in, try to nudge that rather than come up with a more fitting solution because, because none of the things would actually fit. If you're borrowing an older method that had worked before may not work because the problem has shifted, and it's shifted in such a way that the solution is not optimal. That's the best way. It kind of works, but it's not really an optimal solution. It introduces complexity. It produces more of the slop, the AI slop that you're seeing. It's again everybody saying the same thing. It's kind of thing. It's not sitting down and thinking, because it's much more energy inefficient if you have a ready-to-go pattern versus go through the steps, think about it, right? So that's I think the risk of memorizing a lot of the things. Yes, if you're recalling facts, that's great. But if you're creating something new, finding solutions to a problem, yeah, they may not be that great.
And then, that kind of does lead us into, as we were talking about training, to the paper you were starting to mention, which is there was some news late last week about Anthropic being very concerned that DeepSeek and some of the other models are using what's called a distillation. They were calling it a distillation attack. You could call it distillation learning. And we've talked about variations of this even in some of the quantization approaches. But this is the way you can go train a model with data from another model.
Yeah. So you were basically, I think what they were complaining about, that some of the open source models, they were creating tens of thousands of accounts and trying to get the learning piece of it. So you input, you extract what are the thinking patterns to it, right? So because those are hard to get, because if you think about the old school, before the thinking came along, you would basically take a text and cut it in half, and first part you feed it in and see how well the rest of the it's able to emulate, and that difference is your cost function. But now with thinking, that piece you have to manually generate that using a human or some kind of, hey, this is the problem, this is the way to think about it, and then here's the output. Those are additional steps that needs into the fine tuning or building a model or whatever you call it, right? So distilling is one way to get that effect. And often it's seen that you can mimic the actual model really well when you're distilling it rather than quantizing it, because you lose a lot of the tool cunning functions, all of that stuff. I think we covered it in a couple, as you referred, a couple of sessions ago. But distilling is an easy way to do it. Again, it kind of gets to the point, the amount of information out there is finite. the cap is finite on that one. So a lot of these open source models are probably also hitting that. Now, a lot of these companies like Anthropic or OpenAI, they spend a lot of money to generate that thinking steps or curating those data, cleaning those data, right? So, it kind of like, hey, if they can distill it out, they get a more enhanced data set on which they can train. So.
Well, and I think too, particularly because it was DeepSeek, and DeepSeek had made such a big deal about how efficient their training process was and low cost. This provides an easy counterpunch to say, hey, did you really do the work? Anthropic has a lot of ability to say, we spent a lot of time to build this thinking functionality, to build our model and generate these responses and train, and from their perspective, build a lot of responsibility into the model and how it responds. And their argument can be, hey, when you're looking at DeepSeek, is it really as good as they say? Are they as fast as they say? Because look, they copied our homework. They did a lot. They took a lot from us to be able to do their model. And particularly in the current day and age, there's also national security and other things that start to come into this. So it'll be interesting to see where it goes. But I think it's an important thing for those of us from a technical perspective. Remember, there are tools there that we need to use consciously to help build a model, and we shouldn't use them in the wrong ways, but we can use them to go build different things, and we can use them as we optimize our own models with in-house or other things, to have one model train another. You just need to make sure you have permission to do it, you have the ability to do it, you're not violating terms of service and all that kind of stuff.
I mean, one of the risks you touched on is like a lot of these models like Anthropic or OpenAI, they have a lot of guardrails around the model. When you are distilling, a lot of that doesn't carry through that easily because they are not explicitly mentioned out, right? So what's the risk around it? It's kind of interesting to see how that spans out. Maybe they don't have those requirements when they're building open source model, and it's on the users to implement that down the line. So,
yeah, and that gets down to a whole other discussion for another day about whether they're uncensored or jailbroken models and the way people want them to go do stuff. And you've got to, and it is interesting. So I was building a tool that was more for like a game, and I was asking it certain prompts. Certain models will not respond to things. Even if you say this is theoretical, they'll go, I can't do that. And then there are other models that have no problem about the response.
Yeah, it's, I mean, there's also a theoretical limit to what you can achieve in terms of pushing the boundary with distillation, because it's definitely an efficiency gain, but does it push the envelope or not? I don't know that yet, right? So it may be performing really well on the benchmark. Again, we have seen some papers in the past where models are trained to perform well on benchmark because they can identify it's the benchmark test versus a real use case, and they perform differently, right? So it's overfitting to a test environment kind of setup right now, right? So those are to be seen, right? How that plays out well as we roll out the open source models.
So I will share when we post this a link to another video from a guy, Bijan Bowen, who does a lot of interesting AI videos. And one of the ones he did was demonstrating a distillation attack. So I thought that video, just seeing how it worked from a technical perspective, was very interesting, because it's one thing to know it conceptually, but to see like someone going through the steps was, I thought it was an interesting take and an interesting way to communicate exactly what was happening.
Yeah, that would be interesting to see how they use distillation for attack, but that's still trying to get my head around how would that work.
Yeah, it's an attack is probably a strong word, but it is a way, it does get to, in some ways, IP theft, or theft of IP that was questionably obtained when you look at how a lot of the data training. So there's a whole bunch. It's that internet meme of the Spider-Man pointing at each other in some ways.
Yeah, I've seen that meme too. Or the fishing one. One is from the river, from the bucket, and they're chaining through that. True. Yes. I mean, if you think about it in a larger context, that is true. But again, if I look at it from the point of the thinking, none of that thinking step exists. Right? You have the body of, but nobody documents, or very rarely that's documented how you derive from this to that journey, right? So that is being somehow manually curated, or smaller models are involved. That's the IP of those larger model builders, I'd say, right? And distillation kind of shortcuts that if you're extracting that to do it. So yeah, it's not as simple as somebody's copying the copyrighted material to create some of the larger models, because yes, that's the seed, but there's a lot of enrichment that happens in the middle that a lot of people don't get to see. So
yeah, cool. Well, on that note, any other closing thoughts?
No, I'm very excited to see how the M5 Max chips plays out, because I think it's time for an upgrade for me. So it's probably early Christmas, but we'll see.
Well, what I'll say is, like, for me, the M3, when I bought this 2 years ago, you kind of gave me a little bit of a hard time on what am I going to do with that. But I'd seen like being able to run Olama and stuff, and I can run, like when I'm on a plane, like when I'm flying later today, I'll be able to run a lot of stuff local on the plane, even though I don't have a network connection to go use the other tools. Does it mean they'll be perfect? No. Does it mean my lap will get bloody hot? Yes. Does it mean my fellow passengers will be annoyed by my computer's fans screaming at Mach 1? Yes. But I'll be able to do some stuff. So I think there's value to that. And then I think we all are going to have to think about, you're not all, one, you don't always have an internet access. Two, you don't always have the ability to go use a model for different reasons. So how do we find those applications where we can run them local, whether it's on a Mac Mini, on a Mac, on a Spark DGX, on something where you've got some more controls. I think it'll be super cool.
Yeah, I'm excited for that. So this whole, because it's so hard to buy GPUs in this market, or even RAM, right? So having something like that where you can load up a 70B model and tinker something around it. It won't be like a professional grade software, but at least the tinkering phase, POC, MVP, whatever you call it, is the physics works kind of testing, right? So if that happens on your locally laptop when you're down free time, that is an interesting proposition for sure.
And as a data point, I looked up what I paid for my MacBook. The new ones are roughly the same price. They are not for the 128 gigs. It is not a. It's not
a significant jump. Yes, I was afraid that they will mark it up on the RAM prices going up, but they did not. So that was a good piece of news. So
cool. Well, on that note, we thank everyone for joining us. Please like, subscribe. What we particularly want are comments, whether it's on our shorts or on the videos. We'd love to get some feedback on what kind of content you want to see, how we can help bring more of it, or what we can do more of. I do apologize for the audio issues on my end, as I'm traveling and I didn't charge my bank battery. So thank everyone for joining us.
Thanks.